Okay, dear students, once again, welcome back with another class based on the concept of binomial theorem. Okay, and in the previous classes, already we discussed and you have seen how to prove the binomial theorem. Okay, and also we discussed some of the problem based on binomial theorem, how to expand binomial expression. Here is another class, and where I am going to explain how to expand the binomial expression with the help of the binomial theorem. Okay, so let's start. And here is the question. You can see here. Understand? So here expand x plus 1 upon x whole to the power 6. We have to expand using the binomial theorem. Yes, and all of you know, and once again I am writing that formula of the binomial theorem. Okay, here, and all of you know, you see a plus b whole to the power n. Okay, and here summation of NCR a to the power n minus r b to the power r, where r varies from 0 to n, and this is the short format. And the expanded form, all of you know that NCR when r is equal to, here r means what? The value of r, all of you know, 0, 1, 2, 3 up to, here the power is n up to n. Okay, understand? So it means if you write in the expanded form, the first r will be 0, here the first r will be 0 here. Okay, so write NC0 a to the power n minus 0 b to the power 0, then plus. Okay, when r is equal to 0, after the values of r is equal to 0, next value is r is equal to 1, then you write NC1 a to the power n minus 1 b to the power 1. Yes, okay, plus, then after the values of 1, then r value will be 2, NC2 a to the power n minus 2 b to the power 2. In the similar manner, if you proceed, NCR a to the power n minus r b to the power r. Yes, and then last term is NCN. A to the power n minus n b to the power n. This is the in the expanded form of the binomial theorem, and already it is derived or it is proved. All of you know, you have already practiced this. And here is the problem. With the help of this theorem, we have to expand the given expression x plus 1 upon x whole to the power 6. Okay, let us see carefully. First of all, you write the expression x plus x 1 upon, here x plus x 1 upon 6. Okay, you see here x plus 1 upon x whole to the power 6. So you see here in the first term, the first term is x and second term is 1 upon x. It means in place of x, okay, in place of x it is a, in place of b, in place of a it is x, in place of b it is 1 upon x. It means you can write x is equal to, x means what? A here, yes, and 1 by x means what? B here, yes or no? Okay, so if you use this format here, let's see. And here n value, maximum value n is equal to 6, so you have to write the r value will continue, the r value will continue to 0, 1, 2, 3, 4, 5 over to 6. Understand? Since the power of the binomial expression is 6, and all of you know the total number of terms will be 6 plus 1, okay, which is 7 terms. This means this binomial expression will contain 7 terms. Okay, how to find out the number of terms? All of you know, by adding 1 to the power of the given expression, we can find out the total number of terms. And if the power is 6, so by adding 1 to the power, which is 6 plus 1, which is 7, so this binomial expression will have 7 terms. Okay, let's see now. Here first r is equal to 0. The first r is equal to 0, right? Here n is equal to 8. Here n value 6, so write 6c0. In place of a, it is x to the power 6 minus 0 into b. b means what? 1 upon x whole to the power 0. Yes. Similarly plus. Okay. Then 6c1 x to the power. Yes. 6 minus 1 into 1 upon x whole to the power 1. Right. Okay. Then 6c2 x to the power. Yes. 6 minus 2 into 1 upon x whole to the power 2. Okay. Plus 6c3 x to the power 6 minus 3 into 1 upon x whole to the power 3. Yes. Plus 6c4 x to the power 6 minus 4 into 1 upon x whole to the power 4. Plus 6c5 x to the power 6 minus 5 into 1 upon x whole to the power 5. Plus 6c6 x to the power 6 minus 6 into 1 upon x whole to the power 6. Okay, this is how, and it contains 7 terms. 1, 2, 3, 4, 5, 6, 7. Is it clear? Understand? And after finding, when we are expanding the binomial theorem, we have to find out there. Okay, you see the binomial coefficient. I already told you have to simplify. You have to find the values of the binomial coefficient. What are the binomial coefficient? It is 6 is 0. Okay, 6a1, 6c2, 6c3, 6c4, 6c5 and 6c6. These are binomial coefficient. You have to find out the value first of all. We have to find out the value. Yes or no? Yes. What? 6c0, 6c1, 6c2, 6c3, 6c4, 6c5 and it is 6c6, right? Understand? Okay. And all of you know the values of 6c0, nc0 formula. What is nc0? Yes, we know nc0. nc0 is equal to what? 1. Yes or no? And ncn is also 1. And here nc1 is equal to n, right? Okay. So nc0, 6c0, the value will be what? Naturally 1. Yes. Then 6c1 and the 6c1 value what? Which is 6. And 6c2. How to find out 6c2? Let's see. 6c2. We can write 6 power 2 in another way. 6c2 or 6 power 2. It means, and 6 power 2 means here the number is 2. It means you have to multiply the 6 in descending order and twice. Okay. It means give the division sign here 6 into then 1 less than the 6. 6 minus 1 is 5. Okay. And here the number is 2. So you have to find the product of the natural number 1 and 2. Okay. Understand? So after you see cancel here 2 3 is 6 and it is 3 5 it will be 15. It will be 15. And here 6c2 will be 15. Is it clear? Is there any doubt? And similar manner 6c3 or we can write 6 power 3. Yes, we can write, or the 6 into 5 into 4. 3 times 3 factor. And here number 3 means it will be 1 into 2 into 3. Right? Okay. Then you can cancel. You see 2 3 is 6. Here 6 is cancelled. After that 5 4 is 20. Hence you see 6c3 will be value is 20. Once again check. Okay. 6 2 3 is 6 cancel. 5 4 is 20. This is the value of 6c3 or 6 power 3. Okay. The next value is what? 6c4. And 6c4 means what? We can write 6c, one formula already know. If this value will be, R value will increase, then we can use, the value will increase, then this value we can use the another formula. And that formula, just 1 second, I am reminding you. What is that formula? NCR is equal to NCN minus R. This formula. All of you know? Yes, this formula no? Okay, so you can write here, look at here, 6c4, we can write 6c, 6 minus 4. What is 6 minus 4? 6 minus 4 is 2, so 6c2. It means the values of the 6c4 is same as the values of 6c2, and already the value of 6c2, what is the value we got already? 6c2 value already we got what? 15, so you can write 15, hence 6c4. So the values of 6c4 is equal to the values of 6c2, which is 15. So you write down 15. Yes, understand? Okay, is it clear? Are you writing? Yes. Understand? Okay, let's now after that value 6c4 and 6c5, and 6c5 is a 6c5, and which is 6c, 6 minus 5 is 1. So the values of 6c5 is equal to 6c1, or you can write 6 power 1, and 6 power 1 value what? 6 already know, so it is 6, and 6c6, 6c, which is 6 minus 6 0, and you know 6 is 0, value is already 1, we already got it. Yes, the value will be 1. These are the binomial coefficients. So while we are calculating expanding the binomial expression, first of all you have to find out the values of the binomial coefficient, okay, in correct manner. Okay, understand? So after that you can put these values of binomial coefficient. Let's see now. Okay, let us write here. Here you see, look at here. Okay, now see here, first to see 6c0, the values of 6c0 already 1. Okay, 1 into x to the power 6 minus 0, which is 6, and into 1 upon x whole to the power 0 is what? Into 1. Yes, yes or no? 6c0 value 1, x to the power 6 minus 0 is x to the power 6, and 1 upon x whole to the power 0, the power is 0, the value is 1, or you can write this value will be x to the power 6. Is it clear? Then plus 6c1, then you come to 6c1, 6c1 value already 6. Okay, then x to the power 6 minus 6, x to the power 6 minus 1 is 5, 6 minus 1 is 5 into 1 upon x. Yes, then after that 6c2 plus, what is the value of 6c2 is 15. Yes, so it will be x to the power 4 into 1 upon x square, because 1 upon x whole to the power 2 is 1 upon x square. Then value is 63 plus 63 value is what? The 63 value is already we got it what? 20. Yes, 20 we got 20, 63, and x to the power 3 into 1 upon x to the power 3 plus, then after next value coming 64, right? 64, and 64 value what? What is the value of 64? The 64 value what? 15, right? Okay, and x to the power 6 minus 4 is 2. Here 6 minus 4 is 2 into 1 upon x to the power 4. Then plus 65 value is 6 into x to the power 6 minus 5 is 6 into 1 upon x to the power 5. Okay, and last term, and is 66, 66, you see here the value is 66, this value is, and this value is what? 1. Okay, and x to the power 6 minus 6 is 0. Yes, x to the power 0 into 1, x to the power into 1 upon x to the power 6. Yes or no? And the values of 1 is a multiplicative identity, and x to the power 0 value 1, so we can omit this one, so it will 1 upon x to the power 6. Okay, understand? Let us simplify this one. Let us simplify here. See here, look at here, and x to the power 6 plus 6 to the power 6 into x to the power 5 divided by x to the power 1, which is x to the power 4, all of you know, plus, yes, this is 1 upon x to the power 6. Okay, so here you see 6 to the power 4, then third term coming, look at here, 15, x to the power 4 by x to the power 2 is x square, yes, then plus 20, here x cube can you cancel, here x cube can you cancel, value will be 1, so 1 is the multiplicative identity, you can remove it, okay, 15, so 15, here x square by x, it will be x to the power what, x square plus 6, okay, into 6 into x divided by x to the power 5 is x to the power what, 4, yes or no, yes, and plus 1 upon x to the power 6. So this is the desired expression of the given binomial. Okay, is it clear all of you how to expand the binomial expression with the help of the binomial theorem? It is very simple, interesting question for you and also vital questions. And here we are discussing the binomial expression, okay, in the format a plus b whole to the power n format. And next I will discuss a minus b whole to the power n. Okay, if the value will be signed with negative value, if the binomial expression two terms will be related by minus sign, and I will discuss in the next class. Let us discuss some of the problem based on the binomial expression connected by which sign, positive sign, okay. So I hope you are getting understand, okay, and once homework I am giving students and you will do. Okay, what is the homework? Now expand x square plus 1 plus 2 divided by x square whole to the power 7 whole to the power x square whole to the power 7. So this is the homework I am giving you, and you try and send me, okay, understand. So I find if okay, and the problem I hope you will can do it, and you, okay, is it clear all of you? Okay, try this to do how to expand x square plus 2 upon x square whole to the power 7. Okay, thank you. Okay, once again and with another problem. Here I am going to expand the binomial expression with the help of the binomial theorem, which was already given in the previous class as homework, and already you have done it, and just you can rectify your answer. Here x square plus 2 upon x square whole to the power 7. Okay, here is the we have to going to expand, and x square plus 2 upon x square whole to the power 7 whole to the power 7. So you see here the power is 7. It is a binomial expression connected by plus sign, and the power is 7. It means it will have how many terms? 7 plus 1. So number of terms will be 7 plus 1 is equal to 8. So it has 8 terms. How many terms? So it is 8 terms. Let us expand. Okay, and all of you know, as per the formula, the binomial theorem, a plus b whole to the power n, which is summation of NCR a to the power n minus r b to the power r. Okay, where r varies from 0 to n, and here in the expanded form it is nc0 a to the power n minus 0 b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2 plus up to ncr a to the power n minus r b to the power r, and last term is plus ncn a to the power n minus n b to the power n. This is the binomial theorem expanded form. Okay, and let us expand this problem. And in this, here it is a 2 terms connected by plus sign. So here x square means what? Here x square means what? We have taken a. Here x square means what? In place of x square is a, and 2 by x square means b. Okay, in place of a it is x square, in place of b it is 2 upon x square. Let's see now. So here the power is 7. So since power is 7, so it will be 7c. First we start from 7c 0. Okay, here the values of r is 0, 7c 0, and a to the power what? 7 minus 0 into b to the power. B means what? 2 upon x square whole to the power what? 0 plus 7c1. Okay, a means x square whole to the power 7 minus 1 into 2 upon x square whole to the power 1, right? Understand? Then plus, then 7c2 x square whole to the power 7 minus 2 into b means 2 upon x square whole to the power 2, right? Then 7c3 yes, a to the power a means x square 7 minus 3 into 2b means 2 upon x square whole to the power 3, right? And plus 7c4 into a to the power 7 minus 4 into b to the power b means 2 upon x square whole to the power 4. Understand? Whole to the power 4, yes. Plus again 7c5 x square whole to the power 7 minus 5 into 2 upon x square whole to the power what, 5, yes. And plus 7c6 a to the power 7 minus 6 into 2 upon x square whole to the power 6 plus 7c7 into x a to the power it is 7 minus 7 which is 7 minus 7 7 minus 7 into 2 upon x square whole to the power 7. And these are the expansion of the binomial theorem which contains 8 terms. Okay, number of terms is 8 because the power is 7. So let us simplify. So while we are simplifying, first of all we would find out the values of the binomial coefficient. Okay, first of all the NC0, the value of NC0 is what? Is all of you know 1, yes. And the value of NC1 is n, yes. So here in place of n we can write 7. You write 7 because the highest power is 7, yes, 7 and 7. Understand? So 7c0 is 1, 7c1 is 7 and 7c2 means what? 7c2 it means, or you can write 7 power 2, we can write in this another way. Okay, 7 power 2 which is 7 into 6 divided by 1 into 2. Okay, I will cancel, it is 2 3 is 6 and 7 3 is 21. So here 7c2 value 21. Yes or no? Look at here, 7 into 6, 2 3 is 6, 7 3 is 21, right? Yes. After that you write 7c3 means you can write 7 power 3. Okay, and here 7 into 6 into 5, here it will come 3 factors and 1 into 2 into 3. Okay, and let's see now. I will cancel, this will be 2 3 is 6 is cancel and 7 5 is 35. Okay, so 7c3 value 35. Let's write down here 7c3 35. Then you write in 7c4 and 7c4, here 4 value coming means the value is increasing. Since r value increasing, we can use this formula NCR is equal to NC n minus r. Okay, and 7c 7 minus 4 is 3 which is 7c3. It means the 7c4, the values of 7c4 is equal to 7c is equal to the values of 7c3. Yes or no? So already we got 7c3 value what, 35. Yes, so you write 35. Yes or no? Yes. Similarly you write 7c what, 5, 7c5 which is 7c what, 7 minus 5 is 2. The values of 7c5 is equal to values of 7c2. The values of 7c2 values already we got 21. Here we got 7c got 21. Then 7c5 is also 21. So the values of 7c5 is equal to values of 7c2. Okay, understand? Let us note down here how to calculate the binomial coefficient, how to simplify the binomial coefficient. Okay, using the easy process. Okay, and simple formula. Understand? So next point is the 7c what, 7c6, and 7c6 is equal to 7c, yes, 7 minus 6 is 1 and 7c1 value already got what, this is value 7, hence 7c6 value is 7. Yes, and last point is 7c7 is equal to 7c, 7 minus 7 is 0, and 7 minus means the values of 7c is 7. The values of 7c 7 is equal to values of 7c 0, which value is what? 1. So value is 1. Understand? Okay. So this is how you can find out the values of the coefficient, binomial coefficient. Okay. And you see here the binomial coefficient are coming 1, 7, 21, 35, 35, then 21, 7 and 1. Are you understanding, observing a pattern? The binomial coefficient are coming in a pattern according to Pascal triangle. All of you know the Pascal triangle. Okay, understand? So let us write down this expression, 7 values of binomial expression. In the here 7c value is 1, yes, and x to the power 2 whole to the power 7 minus 0 is 7, yes, into 2 upon x to the power 0 is what? 1, yes, understand? Is it clear? So you can eliminate multiplicative identity, okay, plus, and x to the power 2, x to the power 2 whole to the power 7, we can modify next step. Okay, okay, then 7c1, and the values of 7c1 is 7, yes, into x to x square whole to the power how much? 6, into 2 upon x square, because you 2 upon x square whole to the power 1, which is 2 upon x square, then coming 7c2, and 7c2 value which is 21 into x square whole to the power, which is 7 minus 2 is 5, yes, into 2 to the power 2 divided by 2 upon x to the power 2, 2 to the power 2 divided by x to the power 2 whole square, which is x to the power 4, and here you can write 2 to the power 2, in place of 2 to the power root we can find 4 also. Okay, this is 7c2. Next value is 7c3. Okay, and 7c3 value plus 7c3 value is what? What is the value of 7c3? And you can see here 35. So write down 35. Okay, into x to the power 2 whole to the power 7 minus 3 is 4, into 2 to the power 3, which is 8, divided by x to the power 6, yes, okay, understand? Then plus, understand or not? Then 7c 7c3 over 7c4, you see the value 7c4 is also 35. Look at 7c4 is also 35. Then x square whole to the power 7 minus 4 is 3, and here 2 upon x square whole to the power 4, which is 2 to the power 4, which is 16, divided by x square whole to the power 4 is 2 4 ja 8. You can multiply the power to power, 2 4 ja 8. Here x square whole to the power 4, 2 4 ja 8. Then plus, next point you say 7c5. What is the value of 7c5? Yes, the values of 7c5 is also 21. Okay, so 21 into here 7c5, which is x square whole to the power what? 7 minus 5 is 2, into and 2 to the power 5. 2 to the power 5 is what? 32, divided by x square whole to the power 5, x to the power what? 2 5 ja 10, x to the power 10, plus, okay, next point 7c6, and the values of 7c6 value what? 1. 1 is the multiplicative identity. Okay, then x to the power what? You see now 7 minus 6 is 1, so x square you can write into 2 to the power 6, which is what? 64. Yes or no? 2 to the power 6 is 64, and x square whole 6, 2 6 is 12, x to the power 12. Yes or no? Understand? Plus 7c6 value is 1. Okay, and x square whole to the power 0 into 2 to the power 7 divided by x to the power how much? 2 7 is 14, x to the power 14. Understand or not? Okay, this is 64, and 64 2 ja, it will be 128. 128. 2 4 ja 8, 2 6 ja 12. 128. Here 2 to the power 7 value. Okay, so this is how it contains 8 term. Once again check 1 2 3 4 5 6 7 8. Okay, understand? Is it clear? So after finding, let us simplify here. There is more simplification is required. Understand? So note down here. You noted? Okay. Thank you. Let's see. Okay. Then see here. Equal to what? Okay. You see now. First term is x to the power what? X to the power what? 14. X to the power 14. Yes. Plus 7 into x to the power what? 2 6 are 12 into 2 into 2 divided by x square. Yes. Plus 21 into, look at here. Here 21 into 4. Let us arrange the numbers, and into x to the power 2 5 are 10 into 1 upon x to the power 4. Yes. Plus after that 35 into 8 into x to the power 2 4 is 8 into 1 upon x to the power 6. Look at here, 35 here 8 and x to the power 2 4 is 8 and x to the power 6. Then next it is 35 again, 35 into x to the power what? 2 3 is 35 into 16, you write 30 and 16 into x to the power 2 3 is 6 into 1 upon x to the power 8. Yes. Plus 21 x to the power what? 2 2 is 4 x to the power 21 into 32 write down. Here you see 21 and 32 number you write, arrange the numbers, then coefficient to coefficient, variable x to the power 2 to the 4 into 1 upon and x to the power 10. Okay. Then plus here 64 into x square into 1 upon x to the power 12. Understand or not? And last term is x to the power 2 whole 0. Is this 0? The value will be 1. Okay, here 128. Last term will be 128. It will be plus 128 into 1 upon x to the power 14. Okay, understand? Look at, note down. So okay, so after that let us find out the more simplification is required. You see now x to the power 14 plus 7 here 2, 7 to the 14 into x to the power here 12 minus 2 is 10, x to the power 12 that x to the power 2, which is x to the power 12 minus 2 according to laws of exponent, which is 12 minus 2 is 10, plus 21 into 4 is 84. Yes. X to the power 10 minus 4 is 6. Okay. Plus 35 and 8, 8 5 is 40, 0 carry 4, 8 3 is 24 plus 4, 28 into x to the power what? 2, because x to the power 8 by x squared, 8 minus 6 is 2. Okay. Plus here 35 multiplied 16. Okay. 16 5 is 80, 0 carry 8, 16 3 is 48 and 48 plus 8. Okay, it is 56. 56 x to the power 6 by x to the power 8. It will be 1 upon x to the power what? 2. Because x to the power 6 into x to the power 8, it will be x to the power 6, x to the power 6 will be cancelled. It will be 8 minus 6, x square. Okay, understand? So all of you know calculation part. Okay, that should be done in proper manner. Then plus 21 into 32. 21 into 32 multiply. Here 2 1 is 2, 2 2 is 4, 3 1 is 3, 3 2 is 6. It will be 2, 7 and 6, 672. 672. Okay, into 1 upon x to the power 4 divided by x to the power 10, which is x to the power 10 minus 4 is 6, plus 64 here you see x squared and x to the power 12 into 1 upon x to the power 12 minus 2 is 10. Yes, it's okay, understand? After that, and the last term is 128 into 1 upon x to the power 14, 1 upon x to the power 14, right? And this is the once again we can modify here, x to the power 14 plus 14 into x to the power 10 plus 84 x to the power 6 plus 280 x square plus 560 by upon x square is plus 672 upon x to the power 6 is plus 64 divided by x to the power 10 plus 128 to the power, okay, x to the power 14. This is the simplified form, okay, of the expansion of the binomial theorem. You can check of the expansion x square plus 2 upon x square whole to the power 7. Okay, so hope you are finding okay some solution here and you can do it. Okay, is it clear all of you? Let us try to practice some more problem over that. Understand? Okay, in mathematics problem is the most important factor, so more and more problem if you practice, that will be okay, then your efficiency in math will increase. Okay, if you want to speed up your math, so you have to problem solving attitude you have to develop, right? Okay, with this, thank you. I hope you will understand it. Okay, see you, bye.